Well, now we're doing Unit 4B, Part 2. And we're first going to deal with continuous compounding, which means every moment we've got compounding going on, and that formula is on page 220. And it is the amount equals P times E to the n, and in the exponent position we have the annual percentage rate times the number of years. And E is an irrational number. Like pi, it goes on forever and never repeats the decimal. So, anyhow, here's our formula. We're given that P equals $1,384. The rate is 6.7%. The number of years are 5. So when we install those values into our formula in the appropriate positions, we wind up with an amount of accumulated balance of $1,934.75. Now here we're going to, this time, I beg your pardon, we need to find the applied rate. So going through a procedure similar to what we did earlier, we wind up with an applied yield, annual percentage yield, of e to the APR minus 1. And since y is 1 year, where the number of years is 1 times APR is just APR, the rate. So given an annual or a rate of 3.9% when we compute the applied percentage yield, we get a rate of 3.98%. So if you simple interest at 3.98% would give you the same yield at the end of a year as a rate of 3.9% would. Now let's go to 8. And for question 8, we've got two fellows that are saving money, Bill and Ted. And let's go through Bill first. His principal is $7,100. He's going to compound monthly, so n is 12. His interest rate is 4.7%, whereas Ted has a principal of $7,300. He's going to compound annually, and he has a rate of 4.5%. So at the end of 5 years, who has the more money? Well, here's Bill's amount, $8,976.73, but Ted has accumulated more, and it's $9,097.13. On the other hand, after 20 years, we'll recompute letting y equal 20, and Ted now has accumulated $18,142.53 as opposed to Ted, who's accumulated $17,605.51. So now let's move on to question 9, or questions 9 and 10. So for question 9, our task this time is to take this equation and solve for the principal. So to do that, we'll just divide both sides by this factor, and that's what we get. On the other hand, we can move this base up into the numerator simply by changing the sign on the exponent. Now, the amount is $80,000. That's the amount we want. And the number of years is 30. The rate is 12.5%. And it's compounded daily, so n is $365. When we stick those values into the formula, either one of these, what we'll get is $1,882.63. For number 10, we're going to solve for p again, but now we're compounding continuously. So in solving for p, we divide both sides by this factor, and so p equals a over e to the, in the exponent position, APR times y. Or we can have p equals a to the e, and we can move this upstairs if we just change the sign on the exponent, which we've done. Now, the amount is $30,000, the number of years are 18, and the annual percentage rate is 10.9%. When we install those values into our formula, we get $4,218.31. And we're done.